Hello guys, welcome back to the channel. The paper we are solving today is IGCSE Chemistry Feb-March 2024 and this is the paper number 42. Now let's start with the first question. Iron ore contains iron 3 oxide. A blast furnace is given. So this is a question from extraction of metals. They have given you three reactions. Alright. Equation 1 shows the combustion of carbon in the blast furnace. Name the substance which provides the carbon for this reaction. The carbon is provided by coke. It is a form of carbon only. Now, state the purpose of combustion. See, this equation, the first one is a combustion reaction, and we all know that what combustion reactions do. They provide heat. And the second equation, it's calcium carbonate breaking into two different products. So this is thermal decomposition reaction. The equation number 3, calcium oxide, which is a metallic oxide. Metallic oxides are basic in nature, right? So I can call this as a basic, and silicon dioxide, which is a non-metallic oxides, which are acidic in nature. So this is in a way a neutralization reaction. All right. Now, iron 3 oxide Fe2O3 is converted. All right. What are they asking? Calculate the percentage by mass of iron in Fe2O3. So they're asking you the percentage composition of Fe, percentage of Fe in Fe2O3. For this, what you all of you need to do is just figure out how much mass iron is occupying in this compound. As we can see, there are two atoms of iron, so we will say 2 times iron's atomic mass is 56. Let me check it again if it is 56. Yes, you have to take it as 56 divided by total mass of the compound, which will be 2 times 56 plus 3 times 16, and you take the percentage times 100, your answer will come out to be 70%. This is what you need to put here. Now, state the name of the iron ore which consists mainly of iron oxide. So, the ore is hematite, Hematite. Describe how carbon monoxide is formed in the blast furnace. So, we know that the first equation is carbon plus oxygen gives CO2. Then the second equation is carbon again reacts with CO2 to form carbon monoxide. Right? So, what is this? Carbon is reducing carbon dioxide. So, what you need to mention here is that carbon by reduction, you can just frame it like this, that by reduction of carbon dioxide. They're asking you how carbon monoxide is obtained, right? So carbon dioxide is reacted with carbon to form carbon monoxide. What is this carbon doing? Sorry, this will be carbon monoxide, carbon with a single oxygen. Now, what is this carbon doing? This is reducing the number of oxygens this carbon has. So reduction by reduction of carbon dioxide. Alright. Now, part 4, write the symbol equation to show the reaction that occurs when iron 3 oxide is converted to iron. So they're asking you the reduction equation of iron 3 oxide. Fe2O3 plus 3CO giving Fe plus CO2 3 2. I already remember the numbers, but you can balance it. It's fairly simple to do. Here you have 2 iron atoms, so put a 2 here. You have 3 oxygen atoms, and here you have 2 oxygen atoms. So you just need to think about it. And here you already have 3. So just make it 3 here. It will be 6 oxygen atoms, and it is balanced now. Alright. Now, name the chemical process which happens when iron 3 oxide is converted to iron. This is reduction. State the type of reaction shown by equation 2. Which one is equation 2? Oh, equation 2 is this one. So this is thermal decomposition. So you just need to mention thermal decomposition. Now, explain why the reaction in equation 2 can be described as an acid-base reaction. This we just discussed, that calcium oxide is a metallic oxide and metallic oxides are basic in nature. Silicon dioxide is a non-metallic oxide, and non-metallic oxides are acidic in nature. Right? Now, the chemical name of SiO2, this is called as silicon oxide. silicon. Make sure to mention the oxidation state, which is 4 oxide. The common name given to CaSiO3, this is called as slag. You need to remember this. They can ask you directly, what is CaSiO3? It is slag. Now, explain why aluminium is not extracted from its ore using a blast furnace. Fair point, they're just asking you that in some reactions you do electrolysis, in some reactions you do reduction with carbon or reduction with carbon using a blast furnace. So, why is that? I want all of you to just remember this, that all the metals in the top above carbon are extracted by electrolysis because they are more reactive, right? And the carbon and the metals which are below carbon, they are extracted by reduction with carbon or carbon monoxide because they are less reactive than carbon. So carbon can take away their oxygen, right? Just like we discussed here, see this equation Fe2O3 plus CO, what is this carbon monoxide doing? It is removing the oxygen from Fe2O3, right? So it is removing oxygen, hence reducing the less reactive metal. I think you got my point. So the metals above carbon, electrolysis, metals below carbon, extracted by reduction with carbon or carbon monoxide. So state why aluminium is not extracted. Aluminium is above carbon in the reactivity series. So your reasoning should include that it is above the carbon in reactivity series and it is more reactive. You can write any one of these. It is above carbon. I'm too lazy to write above carbon in reactivity series, or you can say more reactive. Got it? Name the process used to extract aluminium. Now we know that it is above carbon, so electrolysis is used. Both iron 3 oxide and aluminum oxide contain metal ions with plus 3 charge. Write electronic configuration of Al3 plus ion. Now, this might look a bit confusing to some of you. Let's go through the basics. We know the configuration of aluminium, right? What is the atomic number of aluminium? 13. So, the configuration should be something like 2, 8, 3. Right? Now, I want you to remember that positive charge means deficiency of electrons. This is just one way to remember this. Positive charge means deficiency of electrons. So you can just assume aluminium lost 3 electrons. Now just think about it. Aluminium in its atomic form had this configuration. Now when it lost 3 electrons, so it should be only 2, 8 now. So the answer is 2, 8. Very simple. Deduce the number of protons and electrons in Fe3 plus ion. Now, for this, we need to know the atomic number of iron, right? And the atomic number of iron is 26. You can check it out in the periodic table. Now, the number of protons always stay the same, right? So, 26 is protons, but now there is a charge of plus 3. Again, plus represents deficiency of electrons. What is the deficiency? 3. So, the electrons will be 23. Next, the elements in group 7 of the periodic table are known as halogens. Already we know this. Identify the halogens with the lowest density. Now you know that as you go from top to bottom, the density increases. So which halogen will be the one with lowest density? Fluorine, because it is on the top. State the purpose of, not purpose, appearance of bromine at room temperature and pressure. It is first of all a liquid, and then you need to mention its color, which is red, brown. Use the periodic table to give the symbol of the halogen with the highest atomic number. Fairly logical. As you go from top to bottom, the atomic number also increases. So give the symbol of the halogen with the highest atomic number. Let's see the periodic table. And you will find in the periodic table that fluorine is there, chlorine is there, bromine is there, iodine is there, astatine is there. Then there is another element with the symbol TS. It's just that you need to look at the periodic table and just write down this symbol. Deduce the number of occupied electron shells in an atom of its element. Deduce the number of occupied electron shells in the atom of this element, how many shells must be there? Hmm, good question. Let's look at the period number of this. The period number in the periodic table which you will find is 7. So the number of shells occupied are 7. Alright. Valence electrons are given by the number of group number, but the number of shells occupied will be given by the periodic number. Alright. Let me just also show it to you. 1 minute. So let's search periodic table. Let's blur. So you'll get the idea. So here you can clearly see, just look at fluorine, then chlorine is there, then bromine is there, then iodine is there, then astatine is there, then TS is there. And it is period number 7. Use the periodic table to give the symbol of the halogen with the highest atomic number. For this, you just need to look at the group of halogens. You will find the atom which is the bottommost, and you will find the symbol to be written there as TS. So you just need to write it there. Now deduce the number of occupied electron shells. See, for the occupied electron shells, period number is useful, and you will find in the periodic table that this element Ts is in the period number 7. And if they sometime ask you to tell the number of valence electrons, so valence electrons are told by the group numbers. Alright. Now, bromine molecules have covalent bonding. Define covalent bonding, they are just asking you. So, covalent bonding is mutual sharing of pair of electrons between two atoms. Name one halide ion which bromine molecules can displace. For this, we know that as you go down the group, the reactivity decreases, which means fluorine is the most reactive out of all the halogens. Right? Now just think about it. Fluorine, chlorine, bromine, iodine. This is the reactivity order. Fluorine first, chlorine second, bromine third, iodine fourth. They're asking you name one halide ion which bromine can displace. See, bromine can displace the ion which is less reactive than bromine, right? And we can say iodide is less reactive, astatide is less reactive, right? So you can just mention iodide. I hope you're getting this logic. As you go down, the reactivity decreases. So bromine needs to be more reactive than the halide ion it is replacing. So iodine is less reactive than bromine. Just mention iodide ion and do not mention iodine. Iodine represents an atom. The halide ions are written with IDE. Alright. Explain why bromine can displace, because bromine is more reactive. So you can just mention bromine is more reactive than iodide. Name a halide compound which can be used to detect presence of water. We clearly know this. It is anhydrous cobalt chloride. And make sure to mention the oxidation state in between in Roman numerals. So cobalt in between Roman numeral 2 chloride. Part F, calcium chloride is an ionic compound. Complete the dot and cross diagram. Alright, and we also have to give the charges on each of the ions. So we know that calcium chloride is CaCl2, and the configuration of calcium is 2,8,8,2. But when it loses 2 electrons, in order to be stable, it becomes 2,8,8. Right, so we can just mention 2 plus here. And calcium will have 3 shells. Currently they have drawn only 2. So let's draw one more here. Just see how perfect my circle is. You should learn. And now you just draw 8 electrons of calcium. So 1, 2, 3, 4, 5, 6, 7 and 8. Now again, chlorine, the configuration of chlorine is 2, 8, 7, but once it gains 1 electron, it becomes 2, 8, 8. Right? It's an ionic compound. Calcium must be losing electron, and chlorine must be gaining electron, right? So each chlorine will gain 1 electron each because they only need 1 electron each for stability. Now again, look at the perfect circle I'm going to draw. Ouch. See this. Now just put 7 electrons first of all of the chlorine atom itself. 6. This is 7th. Now 1 electron it is getting from calcium, so just mark it with a cross. Now the same thing you have to do here. So let me draw it a bit faster. 1, 2, 3, 4, 5, 6, 7, and 1 electron from calcium. So just mark it with a cross. All right. Now, aqueous lead ions are added to aqueous chloride ions. A white precipitate is formed. Name the lead compound which can be used for this reaction. So you can use any soluble lead compound, and the all nitrates are soluble, right? So just use lead nitrate. Lead to nitrate. Make sure to mention it like this. Majority of the times, any compound with oxidation state mention, you also have to mention it in oxidation state form. And the transition metals you also have to mention with oxidation state. All right. Now, write the ionic equation for this reaction. Now, see what they're saying is that lead ions are added to aqueous chloride ions, right? So, lead ions are Pb2 plus, ions are in aqueous form, plus chloride ions, so Cl minus 1, aqueous form. What will it form? It will form lead chloride, so PbCl2. And this is a precipitate because they have mentioned it, so you just write it as S. Name one other insoluble chloride. We know that silver chloride is insoluble, so you can just mention silver chloride. All right. Now, next question. This is a question on acid bases, our favorite. Define the term base. We know that bases are proton acceptors. You just mention proton acceptors. State what is meant by term alkali. We know that see, bases are there. Now there are some soluble bases which are soluble in water, and there are insoluble bases. So what are alkalis? Alkalis are bases which are soluble in water. So soluble in water, or you can just mention a soluble base. Thymophthalene is an indicator. All right. State the color of thymophthalene. For thymophthalene, you just need to remember it goes from colorless to blue. Try to learn it like this. Colorless to blue. So in acid it is colorless, in base it is blue. Alright. Now NaOH. Is it an acid? Yes? No? No. It's not an acid, it's a base, it's an alkali. So what will be the color? Colorless. Are you sure? No, it's blue. I mentioned colorless to blue and acid first, base later on. So now this is a base, it should be blue color here. This is an acid, it should be colorless here. Alright, try to remember it like this. pH goes from bottom to top, right? Bottom there is always acid. Lower pH is always acid. So colorless acid and base is blue. Or remember BB, your favorite word, right? Use the information in table 3.1 to identify the substance with highest concentration. We know that strong acids have highest concentration of H plus ions. Now let's look at the table. Is this an acid? No. Is this an acid? No. Is this an acid? No. Is this an acid? Yes. Is this an acid? Yes. Now you compare the pH, pH4, pH1. Which one is stronger? The lower pH, more acidic it is. So HNO3 should be your answer. And the reason should be that it has the lowest pH. That is how you figured it out, right? So lowest pH. Name an indicator. You can just use a universal indicator, let's say. Use universal indicator here. Now, complete the equation. We know that ethanoic acid, a weak acid, weak acids partially dissociate. So, your equation should be first of all with an equilibrium symbol, then mention CH3COO negative with aqueous plus H plus, then aqueous. Alright, just remember that only this hydrogen goes away when it dissociates. Now, write the ionic equation which represents a neutralization reaction between any acid and any alkali. Now, any acid, any alkali, let's say we are picking the general example, NaOH plus HCl. So what happens here? What happens is Na plus and OH negative H plus and Cl negative. So Na combines with Cl, forms NaCl, which we already know, and H plus combines with OH. So this is the common reaction which happens in all neutralization reactions, right? So let me just erase this. Your answer should be H plus plus OH minus, giving H2O. All right. Now we have a topic question from stoichiometry. So let's start solving this. Dilute nitric acid reacts with aqueous calcium chloride. So, all right. And it looks like a titration question, typical titration question. The concentration of calcium hydroxide is given and volume is given. All right. And the volume of HNO3 is given. What are they asking us? Use the following steps. Calculate the number of calcium hydroxide. So, see, for calcium hydroxide, you know the concentration, you know the volume. Just be sure and make sure you convert centimeter cube into dm cube. So, divide 20 by 1000, it will convert into dm cube. Then you know that concentration is equals to moles over volume, right? So, moles will be equals to concentration into volume. Concentration is how much? 0.015. Volume is how much? 20 over 1000, which is 0.02. You multiply them, 0.0, bad with maths, 0.015 times 0.02. So the answer is coming out to be 0.0003, or you can write it in standard form, your choice. Determine the number of moles of HNO3 which react with calcium hydroxide. For this, you need to use the ratio. Check the ratio between calcium hydroxide and nitric acid. It is 1 is to 2, right? So you just double the moles. So 0.0006. Now, in case any one of you has this doubt that we also have a formula given volume over 24 decimeter cube. Why are we not using that? Because HNO3's volume is given. So why not just divide 24 over 24? Sorry, 25 over 24. Why not do that? Because this formula is only for gases. All right, and this is not a gas. In these kind of question, you need to use the ratio. Now, calculate the concentration of HNO3. Now, it's a very simple question. Just think about it. For calcium nitric acid, you know the moles, 0.0006, and you also know the volume, HNO3, 25 centimeter cube. So 25 divided by 1000. Just need to convert it into dm cube, right? So 0.025. You need to find the concentration, so just divide both of them. So 0.0006 divided by 0.025. Your answer will come out to be 0.024 moles per decimeter cube. All right. Now, calculate the concentration of HNO3 in grams per decimeter cube. Now, after seeing this question, a lot of children get confused. This question troubles a lot of them, but it's very simple. Just hear me out properly. This concentration, you know, is in moles per dm cube, right? When you multiply moles with molar mass, see, moles is equals to given mass by molecular mass, right? When you multiply moles with molecular mass, you get the given mass. So what you simply need to do is, whenever you know the concentration in moles per dm cube, simply multiply it with molar mass of that compound and you will get in grams per dm cube. All right, and the molar mass of HNO3 is 63. So you just multiply with 63 and your answer will come in grams per dm cube, which will be 1.51. Next question, the equation for the reaction between methanoic acid and ethanol. We know that this is an esterification reaction and delta H is negative, so exothermic reaction, good point. In the equation, methanoic acid is represented by the formula HCOOH. Now, does this look like a structural formula, condensed formula, or a displayed formula? This is just a structural formula, right? So, structural formula. A lot of children have this misconception that the structural formula is the one where you draw it like this, properly showing all the bonds. No, this is not the structural formula. This is the displayed formula when you're displaying all the bonds. All right. Write the empirical formula of methanoic acid. See, just think about it. One carbon is there, two oxygen are there, and two hydrogen is there, right? So you can just mention CH2O2. How else can you simplify this? CH2O2. Name and draw the displayed formula of ester X. Now, for this, I'll tell you a short trick. Alcohol gives you alkyl and acid gives you OAT. I'm sure all of you are familiar with how esters are named. I'll give you an example of an ester: methyl ethanoate. Alright, now what it means is, I'm just giving you a short trick, that alcohol gives you the yl part. So this is methyl. Now you get the point. This must be made from methanol, right? And the acid gives you the OAT part. So it must be, this ethanoic must be made from ethanoic acid, right? Now just think about it. This is ethanol. So this should be ethyl in the ester name. This is methanoic acid. So it should be methanoate. Alright. I also have a video for this on YouTube. Just make sure to watch it regarding esterification, and I think you will get clear with it. So, OAT is given by acid, alcohol gives you the yl part. Draw a name and draw name we have already done. So, ethyl methanoate. Now, draw the structure formula. So, for this, we know that ester looks like this: C double bond O, O. Then there is a carbon chain here. Now, ethyl methanoate is the formula. So, ethyl should be here. And methanoate is, this should be your answer. Alright, ethyl methanoate. The molecule or the chain right next to the single bonded oxygen will be the alcohol chain. And we know that alcohol chain is made up of two carbons, so two carbons here. And acid was only one carbon, so only one carbon is. Alright. Now, this topic is a bit complicated for some students. Just go through it, revisit your notes. In case you have doubts, just let me know. The reaction is reversible and reaches an equilibrium within a closed system. What does closed system means? So I think closed system means where everything can escape. Is that right? No. So where nothing can escape or leave. State 2 characteristics of equilibrium. We know that first we need to mention rate of forward reaction is equals to rate of reverse reaction or backward reaction. Second, concentration of reactants and products is constant. Sometimes children end up mentioning concentration is same. It is not overall same. It doesn't stay same for all the time. Sometimes it might be, sometimes it might not be. Alright? But it stays constant. That is true. So rate of forward reaction is equals to rate of backward reaction, and concentration is constant. Now, another equilibrium question. Complete 4.1 to show the effect, if any, on the concentration of X. What is X? X was the ester, I think, right? So it's our product. When the temperature is decreased, now it's an exothermic reaction. How do I know? On the top it was mentioned delta H is negative. And in exothermic reaction, as temperature is decreased, it favors forward reaction. Now, just think about it. If you're favoring forward reaction, means you're going towards the product. So the product should increase. Very logical, I think. Increase. Now, if you're decreasing the concentration of HCOOH, let me write down the equation here to make you understand. Concentration of HCOOH is decreased. Now, you can use a method for this. Just consider it to be a seesaw. Now, just think about it. Currently, it is balanced, but now what you're doing is you're decreasing the reactant, right? So, the product side must get heavier then. The seesaw will start looking like this, right? Now, in order to balance this, where will you go? Towards the backward side, right? So, backward side is towards the reactant. So, you just mention concentration of HCOH is decreased, so what happens to the concentration of X? If you're going backward, you're going away from X, so decreases. Let me explain it to you once again. This is just a trick that I have developed in order to solve the concentration questions. You use a balance, and initially it is an equilibrium, so everything is balanced. But now you are decreasing HCOH. If you're decreasing the reactant, product will get heavier. So it will start looking like this now. And in order to balance this, where will you go? You will shift something towards the backward side in order to balance, right? And if you're going backward, what will happen? You're going towards the reactant, means the concentration of HCOH, the concentration of X will decrease. Now, concentration of both HCOH and CH3CH2OH are decreased. Now, the answer will come out to be the same here, but again, let me explain this. So, this is the initial condition. Now, what you're doing is you're making the reactants very light, right? So, again, the products will dominate, products will get heavier, so the balance will start looking like this. Now, in order to balance this, you will go to the backward side again. And if you're going to the backward side, means you're going towards the reactants. And if you're going towards the reactant, product will decrease. So, decreases. The catalyst is removed. We know that the catalyst does not affect equilibrium, so no change. All right. Still, if you do not understand this concept, make sure to let me know in the comment section. I'll be more than happy to explain. All right. Butane and butanene are colorless gases at room temperature. Suggest why butanene diffuses quicker than butane. It's because butanene has low molecular mass. Now you might be thinking how? This is also 4 carbon, this is also 4 carbon, right? But this is a double bonded. This is an alkene, this is alkane. Alkanes with same carbon are heavier, right? This is C4H10. This is C4H8. Which one is heavier? Butane is heavy. So you just need to mention butanene has low molecular mass. Alright. Identify the product formed when butane undergoes complete combustion. Complete combustion, so we know that CO2 and H2 are formed. So just mention CO2 and water. One molecule of butane reacts with alright. During the reaction, one hydrogen atom in butane is replaced. Alright, this is substitution. Alright. Name the type of reaction which needs ultraviolet light. Now, what kind of reaction needs ultraviolet light? Photochemical reaction. So just mention photochemical. State the purpose of ultraviolet light. So the ultraviolet light, what it does is it provide activation energy. So you just mention provide activation energy. Name the type of reaction which takes place when one atom of chlorine. So this is substitution. They're directly telling this to you that one atom is replacing. What is replacement? Substitution reaction. And the question they're telling you the answer is just another word they're using. Determine how many structural isomers can form during this reaction. Now, what are we reacting? We are reacting butane with chlorine. All right. So butane is this. You're reacting it with chlorine. Now, this will take some time and it's very time consuming drawing all the hydrogens. So see what are the chances? Chlorine can attach to the first carbon or it can attach to the second carbon. In case you're thinking why not the third carbon, fourth carbon, then the numbering will start from that way. Right? Then we start counting from where. So it's the same thing. So determine how many structural isomers. Only butane. Wait, there is some problem. Give me 1 minute. How many structural isomers can form there during this reaction? So only two. All right. Chlorine can attach at the first carbon or it can attach to the second carbon. So answer should be two. Now identify the type of catalyst used in this reaction. Which reaction? Butene reacting with steam. So this is an addition reaction which is specifically called as hydration reaction. What does hydrating means? Drinking water, drinking liquids, drinking fluids, right? So when butene drinks steam, not drinks, it reacts with steam. So that is hydration. It's H2O, right? So just assume. Identify the type of catalyst. It is acid catalyst. All right, you just need to remember acid catalyst. They're asking you the type, not the name. Name and draw the two displayed formulas of two possible products. And these two possible products, they are asking us for the D part. So see, it's fairly simple. Let's put hydrogens again, just to make you understand. Let's make this easier for you. So now what can happen is, from H2O, H and OH, there's a possibility OH might attach to the first carbon. Then there is a possibility it might attach to the second carbon, right? Because the double bond is present on the first and second. So what do? We draw both. First I'm drawing OH here, then remaining H you just need to put. This will be your displayed formula. What will be the name? Butane dash 1 dash all. Second one will be, now you put it on the second carbon OH, then just satisfy the valency. Create 4 bonds for each carbon. Butane 2 all. Why 2? Because 2 is representing the position. It's on the second carbon. Butanene undergoes polymerization. State the type of polymerization butanene goes. We know that alkenes undergo addition polymerization. So your answer should be addition polymerization. Alright, so just mention addition. You just need to mention addition polymerization here. Now, the last part, draw part of the polymer molecule to show 3 repeat units. And a lot of students find this a little bit problematic. Let's understand. See, first of all, let's draw the regular structure of butanene. At least we first of all need to know what butanene looks like. Only then you will be able to draw the 3 repeat units, right? So let's draw butanene, 4 carbons and double bond here, then CH2, 1 hydrogen, 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 hydrogen. Now we know that polymerization, addition polymerization takes place from the area of double bond, right? Double bond, out of double bond, one bond gets broken, then the chain repeats. So we need to arrange this, and rest should be in the substituents, right? So you write it like this: C double bond CH2. You can write it like this: C double bond CH. Let's put the HH on the top. Now this you can condense in the form of C2H5, right? And this C2H5 is bonded to this carbon. So put C2H5 here and 1 hydrogen here. Alright, now what you can do is you can draw 3 units like this. C2H5 and H, another unit, because you have to draw 3 repeat units. Now simply just erase the eraser is a bit. Now simply just erase the bond here, this bond, this bond, this bond, and allow them to form a bond between like this, like this, like this. This is your answer. Alright, this is your answer.